Okay. So in this case, we have three equations right here, and we are asked to obtain their corresponding equations in the Cartesian plane. Well, so let's go back to the definitions from the previous. Well, to avoid flipping pages, I'm just going to write these definitions here. X equals r cos theta, y equals r sine theta, and on the other hand, we will use r equals the square root of x squared plus y squared, and theta to be arctan of y over x. All right, which from here follows that tangent equals y over x. So we may be using one or the other. All right. So well, r equals to 5. So well, when you read this equation, r equals to 5, what's the first thing that comes to your mind? The radius of what? There's only one shape, right? Only one geometric shape that has for which one of its properties we refer as the radius. Which one is it? The circle, right? So this means that after we do the algebraic transformation from Cartesian to polar, our resulting equation has to look like that of a circle. Well, how are we going to do that? Well, so we're going to use the properties. So what you might want to do is relate this r with this r right here. So I'm going to replace with that. So square root of x squared plus y squared equals to 5. And we can get rid of the radical by squaring both sides. That's x squared plus y squared equals to 25. So that's the equation in Cartesian plane, or in Cartesian coordinates. Does that look like the equation of a circle? Does that look like the equation of a circle of radius 5? Yes. Let's plot the equation. So the conversions have to be consistent with what we would be expecting. So 5, 5, negative 5, negative 5. All right, letter B. And well, what do we have? Theta equals pi over 4. Well, so for letter A, we'll look at r equals to 5. Well, so that gave us somehow a hint that we would be a circle because, well, that's the only geometric shape for which we relate to a radius, right? Now, what about theta equals pi over 4? What comes to your mind when you see this statement right here?
A line at that angle?
It's just a line at that angle, right? So we would be plotting all points in the Cartesian plane that are pi over 4. Well, that are an angle of pi over 4 with respect to the horizontal axis. Well, we don't call it the horizontal axis anymore. What's the name again of the horizontal axis in the polar system? The polar angle. I mean, the polar axis. Okay. So now, what are we going to do in this case? So this is what we're going to do. Let me rewrite the equation first. Theta equals, I'm going to leave a space here, pi over 4, and I'm going to take tangent on both sides. All right, so on the right hand side, what's tangent of pi over 4? 1. And tangent theta actually gets replaced with this relation here, which is y over x. And well, what's y over x equals 1? We can solve for y. Y equals to x. And that's just the diagonal line, isn't it? That's just a diagonal line. with a slope equals to 1, rise 1, run 1, and passes through the origin. Now, is the graph of this line consistent with the idea we had before? Is this line the set of all points that are an angle of pi over 4 from the x-axis, in this case, now that we're in the Cartesian coordinate system? Yes, is it consistent? All right. So that's what it is. Okay. Let's look at letter C. R equals to 2 cosine theta. And well, if this is the first time you see this, well, this may not be that straightforward to go with. So I'm going to give you I'm going to give away the first step. Okay, let me write it down first. So in this case, what we're going to do is multiply both sides by r. Okay. This will become r squared equals 2 times r cosine theta. And then from here, we can relate what r squared is. Again, another relation that might be useful from here, keep in mind that r squared equals x squared plus y squared, isn't it? And then just replace r squared with x squared plus y squared. And there is another definition here that you might want to consider. R cosine theta, what is that equal to? Isn't that x? And 2x. Well, so that's the equation in Cartesian coordinates. However, it's not yet in the form that it's going to tell us what's the conic section, for example, or the set of all points that really describe. But I mean, looking at x squared plus y squared, they're both positive, they're both squared, and there's no denominators or coefficient. That tells us it's a circle. But I'm worried about that 2x term on the right hand side. So what I'm going to do, I'm going to send it to the left hand side with the opposite sign. X squared minus 2x plus blank, because we're going to complete the square, plus y squared equals to 0 plus blank, because if I add a blank on one side of the equation, then we have to add another blank on the other side of the equation. Well, let's see. So let's fill in the blank with the actual value. So to complete the square, recall that we divide the coefficient of x to the first power by 2 and then square. So negative 2 over 2, that's negative 1. Negative 1 squared is 1. And we can factor the perfect square trinomial, x minus 2, or rather x minus 1 squared plus y squared equals to 1. And now it looks like the x minus h squared plus y minus k squared equals to r squared. From there, let's list what the center is and what the radius is. The center 1, 0, and the radius r equals to 1. And let's plot the graph. So having the center (1, 0), and then 1 unit up, 1 down, 1 right, 1 left. That's our circle. All right. So yes, it's not just, like using the relation. I mean, these relations to convert back and forth between polar and what's it called? in Cartesian, I mean, they're pretty easy to memorize. There's nothing really crazy about. But the important thing here is to really see what we're doing, which is the graphs of the functions. Okay. All right. So